Hey, everybody. Welcome to episode 3 of AI Insights with Robert and Adam. Today is going to be a great topic. We're going to talk about how LLMs think. So the title of our episode is going to be Fancy Autocomplete or Emerging Intelligence, Peering into the AI Brain. So welcome back. Thanks for joining me again, Adam.
Yep, glad to be here.
Well, for those of you who watched or listened to our last episode, we talked about agentic AI. We do have a couple updates from that episode. If you remember, I mentioned we were testing ChatGPT against the NCAA basketball brackets, both men and women's. So I do have the final standings. On the men's side, ChatGPT did amazing. Finished 2nd out of 11, beat everyone in my family, including me, because I finished 4th, and it was a very close race for first place, but a human won. And then on the women's side, we crushed ChatGPT. And if you remember, ChatGPT just did not have the information to really put together a good women's bracket, and so it finished 7th, and I finished 2nd. So and it was a close race for first place. My 10-year-old son won that one, so he walks away with the pride and the award for winning the NCAA tournament bracket for us. But hey, the key thing that I took away from that is next year, 1, I'm using ChatGPT for the men's bracket, and 2, I won't trust a thing it says about the women's bracket until it builds up enough media information to really go off of. So that's the lesson I learned from that, is it just didn't have the data to do right by predicting the winners.
Time to bring an agent in to do web search, and
it did.
Use deep research.
I use deep research for that, and you can follow along on the side. It's research, and it got caught up on some weird stuff as it was going through. Not on the men's bracket, but on the women's bracket, definitely got caught into a weird place and just went down a rabbit hole that it couldn't get out of. And it was bad. But on the men's side, there's so much analysis and so much information out there that it did great. So
fantastic.
Yeah. So I'm gonna enter a ton of different contests next year using ChatGPT as my picker. Well, hey, today we're going to talk about whether or not these LLMs are just fancy autocompletes, just picking the next word, or if there's actually some understanding going on there. This came from an article you flagged from Anthropic about how they were trying to understand what's going on in the mind of an LLM. So what drew you to that article?
I've heard for some time they don't exactly understand how they work. These models are different than standard software engineering, where the model is actually grown. So as they're training it, it's growing the model, which I guess is one way to say it. But they don't exactly have the ability to go in until some of the research they're doing recently to understand what did it grow and what did it start to connect. And it's building out this massive neural network, which again is kind of patterned off the way the human brain starts making associations and concepts, and words are one piece of it, but it's actually building out contextualizations between things that are unrelated, very much the way the human brain does. So the article is really fascinating. I thought it would be a fun topic to dive into. I don't know that I could do it justice because the way that some of the research papers describe it, it's very interesting, and I think they're still confused about how some of this works. So further research to be had.
Yeah. Well, I was thinking back as I was reading the articles. There was a Time article as well that I was referencing. The thing that struck me was, last year I was putting together presentations on how LLMs worked, and so that was part of board presentations and training we were doing across the organizations. And I think I had a great set of slides that just talked about the percentage. How LLMs looked at the percentage likeliness, took into account, how creative you were allowing it to be, and then you ended up with essentially a random sentence with some probabilities based on, how creative you allowed it. And I thought it was super interesting to think that yeah, that's probably not how it's working anymore. It made perfect sense to me. I had developed my mental model based on that of how all this was going to go down, and I think the research, at least of Claude, is showing that there's more to it than just that probabilistic next word piece, which is exciting. I mean, I actually was having this conversation in a bar this last week with a bunch of friends after pickleball, and talking about trying to explain what it was, and that was prior to reading the article. And now I've got to go back and have a new class in the bar over a beer around what's really going on, and understanding, like trying to piece together what's happening between the things. So it's crazy to think about it, what it's going on. I think it's kind of important to talk a little bit about what Anthropic did, and the fact that you called it out, like, hey, this neural network is essentially a mathematical representation of a brain. Like, that's the goal, right? To get to AGI and have the essentially code act as a brain. And if you think about it as where it's at, I mean, we even call it a neural network representing kind of the brain structures. But we'd go for brain scans, and you'd be able to see different regions firing for different tasks, and people know, okay, that's where color is stored, and that's where sarcasm is stored. Yeah. And the way the article described it is they were starting to see clusters of activity for different things, whether it was, in one example, rhyming, and another example seeing math or color, which is awesome. I mean, the whole idea that the grown LLM has now started to figure out that whole node mentality and the whole domain kind of expertise, I think is really cool. And then to be able to go have a tool to go see that, pretty awesome.
Yeah, like a brain scanner for an LLM was really a fascinating concept. And
yeah,
they wanted the microscope to peer into how does this model function. So I know as they did this research, right, they got the results out, and this is not like a brain scanning machine where they can get the subtotal. It was something where they're trying to make representation of, I don't know, numbers, ones and zeros, and weights, and it took them just to go through the one example that they were illustrating in the white paper that they put out. I think it took them months to decompose it, or to unpack it, or month and a half, something like that. So it was a difficult study on a very simple ask. It's not like they asked it a complex problem, or reasoning was involved. It was a very simple prompt, if you will.
Yeah. Well, and so the first example they used was a small poem. They gave it like 5 words. It ended with rabbit, the word rabbit, and they asked it to complete the second line of the poem. So another 5 words, so 10 words total. And they were surprised to see, one, it rhymed it, which isn't the expected outcome if you're just asking it to autocomplete
a sentence. Yeah.
And the fact that it knew ahead of time that it needed to rhyme and factored that into its algorithm to get to that, that was pretty cool. I mean, you and I, if we were asked to do it, that would be the first thing we'd look at. What's the last word? Can anything rhyme with rabbit? Grab it. I don't know, something else. But it even broke it down. It said even further when they looked at it, and it just looked at the it, which is, ultimately what we would do if we were trying to rhyme something. And that's cool when if you're thinking about it as it just goes token by token or word by word. But in this case, it had to holistically look at it, understand the last piece, was it, and it wanted to rhyme with that. So like set something out here, and then as it built its word, it had to make sense. Theoretically, it didn't really have to. I mean, I guess it could. I mean, they did talk like that's starting how potentially hallucinations start to happen, is it goes off track because it doesn't make sense to us, but it would make sense to it. But I just thought that was really cool, though, that it had to pre-think about the rhyming.
One of the big things that kind of bubbled up about this, and I think they started to change parameters, right? They started to change weightings.
Yeah.
Was that it didn't necessarily follow the statistical weighting that you would expect in the human language, which is what you're saying. And so they went back to do this study with boosting. I think it was like Golden Gate Bridge or something like
Right.
that. Everything that came out of it had to do with the Golden Gate Bridge, and you go, okay, well, like
Yeah.
they biased this thing, but um, the fact that it didn't follow like that probabilistic language was the interesting piece. So it knew something conceptually about this pattern of words
Yeah.
has this thing called a rhyme,
Yeah.
and it was able to complete it. So
Yeah.
that was the first piece of the study.
Yeah. And I think there's probably some interesting things around the hallucination piece that kind of factor from that, because it's obviously trying to create a cohesive picture, but then if it goes back and it starts working through and the probabilities don't line up to a cohesive sentence, but it still puts it out there, you're going to have kind of a wonky output. So I think that starts to help me kind of build my mental model around, like, why do you have something that sounds so good be so wrong? Yeah. So the second example I thought was really interesting, and the whole premise was, okay, it's great. Here's how it's doing from a language perspective. Why do these models, why are they not good at math?
Yeah, why are they so bad at math?
And I think I'm gonna read a little bit here because I think this one's really interesting. So the study asked Claude to add 36 and 59. So for all of us, it's 95. And they watched what it did from a steps perspective. And they said it took approximate values. So it was like 40-ish and 60-ish and added those together. And then it refined it a little and took 57-ish and 36-ish and brought those together and ended up with 92-ish. And then it was like, hey, the last numbers of what you asked me are 6 and 9, so it has to end in a 5. And so something that ends in a 5 that's near 92 is 95. So the answer is 95.
Yep.
Like, that is wild. So then they asked it, how did you get that answer? Expecting it to tell it what it really did. And instead it said, I added the ones column, 6 and 9, carried the 1, added the tens column, and I got to 95. And I'm like, you did not.
Not what it did.
That is so complex. I mean, sometimes when I do math in my head, I'll round like that. I'll go to the 60 and 40 and know that it's somewhat less than that. But that's not the general way I do math in my head. That's like, maybe if I'm doing a really big number, I'll do it like that. But that's an odd pattern to approximate something like that, and then feels like guessing.
Maybe they're onto something. This is a new school of thought they're going to teach the kids at school.
No, I will fail those. That's always been fun when, as the kids bring home new homework and they're like, Dad, you can't do it that way. I'm like, but I'm doing it right. You got the right answer. I promise you, this is the way to do it. Yeah, so maybe LLMs will totally change the way we think about math, and it'll be this weird approximation pattern to get to a simple addition problem.
It may be faster. I don't know.
Yeah, maybe. But so I think the question here is like, okay, so it's doing this weird math. How do you trust it? And the bigger implications for this are, hey, let's think about if I'm going to let an LLM, or if I'm going to let generative AI in general, some agent with LLMs attached to it, make decisions for me. Can I approve this invoice? Does it match the PO? Can I approve a loan based on X, Y, and Z criteria? Those are pretty, arithmetic intense, not high math, but, standard arithmetic. And very honestly, I think if you tell a CFO that I'm going to approximate it as I figure it out, maybe that's not such a good thing.
I don't think that's going to pass.
No. And that's what's interesting here is that, why this is important and why I think this study is so critical is, you and I have been through it. We want to understand how the LLMs are coming up with stuff. And so if we can't trust it, or if it does weird stuff that just doesn't feel right, but maybe gets the right answer sometimes, I don't think you're going to go for that. And I mean, we talked about it last time. So you were leveraging Claude Code to write code and to be able to go through a repository and start building stuff. Would you feel more comfortable if you understood how it went through that repository and created stuff, or do you trust it?
I You have to validate the output again, just like you know the autocomplete version as you described, and maybe where models were not too, could have been last week, 10
Yeah.
months ago, a year ago. um, I think you definitely have to validate it. They are getting better. And one thing, maybe they're not good at math, but where models seem to do well, or at least I think people agree, is summarizations and
Yeah.
classifications.
Yeah.
So, if I don't know, I guess if you were asking your model to approve a PO based on a classification and the classification was off, that might be something that you want to flag, but it could
Yeah.
be done very quickly with an LLM.
Yeah.
Maybe not adding the numbers yet. So
Yeah.
maybe they'll improve that function.
Yeah, but I mean, that's the thing, right? So if they don't understand how it works today, and we're just now kind of finding how it works, and they're not actually coding this, how do you improve it? Like, how do you teach an LLM to do math the way we were taught in first and second grade or kindergarten or whatnot? Like, how do you get it to? I mean, I guess you could just keep feeding it kindergarten books and because I think that's important. Like, as these continue to go, and I think as businesses start to use them more, um, I mean, recent articles have come out that said, companies saying, "Hey, we're going to be AI first. You can't hire somebody unless you can show me that it can't be done with AI." Well, I can possibly have it done with AI, but I don't know that it's right. Like, it can physically complete the task, but there's a 10% chance it was wrong. Like, how do you factor that into a business? You keep extra people to keep looking
Check.
at it and doing the same work over and over, like you're just redoing it. But I mean, I think that's the hard part, is until you feel comfortable that it can do things like that, you've got to kind of constrain it. You've got to put some guardrails around it.
And I think a lot of businesses are looking at it. So there's still this concept of human in the loop.
Yeah.
How long does it take to unpack and verify maybe exact matches, line items off of that PO, right? And
Right.
and maybe does this match the original? And the time that it would take to pull those up and do the analysis, you can program an agent to do that.
Right.
So again, it's like within limitations, like the maybe you hire an intern to do stuff like that and go through and verify and do these
Yeah.
things, balance and check. Potentially you can start to spoon feed complex tasks, very very pointed complex tasks. And when you look at stacking complex tasks up, it
Yeah.
becomes a compelling proposition.
Yeah.
And then maybe, at the end somebody has to verify and approve it, but
Yeah.
it's all been put together for you.
So
So
with all that, are there places where you're still a little unsure about letting it go, or are you getting more comfortable? Like, what's your current take on it?
um, I would say an LLM is very good. Like if you do encode, an LLM is very good at putting together a structure. Sometimes it gets its own idea of what it thinks the best structure might be, but
Yeah.
again, that may be based on what quality of prompt did you give it,
Yeah.
or did you give it, an exist like if you went greenfield in a repository. But if you had a structure or you had a template, or if you gave it instructions and said, okay, I want a processor, I want to use Node, I want to like give me best practices with the source folder and docs, and like
Right.
you can give that in a prompt and it's going to follow it pretty nicely.
Right.
And or you could say recommend one, and you could say, yeah, I don't agree. You can, in an agentic flow, you can now give it additional prompts to change its direction, while
Right.
it's either going down the wrong path, or you can stop it.
Yeah.
And so if you think about what the LLM's going to output, it's going to consume something in and it's going to make a recommendation. There's a code
Yeah.
review process still.
Yeah.
You could let it go. I don't know what it's going to do at the end. I mean,
Right.
maybe you just say, I trust this thing. and then I'll go back and fix everything that I don't
Yeah.
like about it. But that may not be so efficient. So you can kind of review it. So,
Right.
yeah, this looks good. I don't know. An LLM's always, always. So if you think about how a human does things, they're generating code that, um, if there's an error, it's going to spit an error out. LLMs love to put a fallback in there with fake data. It's like, you asked me to put this together, and
Yeah.
well, because that didn't work, I'm going to show you what I know will work, and it controls the full thing. So
Yeah.
anytime data is involved, it always builds in a fallback, or I guess it's inclined to build a fallback,
Yeah.
which is interesting. So on one hand, you would look at that and go, oh, it fixed a bug, and it put in nice like quality error handling and notations, or whatever um, might take a human to do longer. It does better at that.
Right.
But very long, complex. I don't think it's there yet. At
Yeah.
least it's
Yeah.
not going to
And
build it from ground to zero.
right. And I like you were talking about, like my worry is, if you have small margins of error and then you let an agent go and it introduces that small margin of error in the 35 steps, maybe it only introduces that small margin of error in 17 of the steps. That's still a really big deviation from where you're hoping it gets. And so I think the thing I'm going to be watching is like, how do you do the back loops to make sure that it rethinks and stops going forward with those small margins of error, and so that it doesn't continue to grow. And that's when I'll start to feel more comfortable, because I'm still a little concerned around, like, I think the agentic AI is awesome. I mean, we talked about that last time, and the things you can do and the use cases you can solve are pretty massive. And maybe you start with your less business critical ones, the ones that, like you said, maybe you've got an intern doing today, or you can have now an intern do the role, and you can start to become more operationally efficient using it.
Yep.
But then I think you still have to. My comfort level is still, when math's involved, I still want a little bit more validation there. I love it for the creative tasks and for the summarization tasks. I love it for things like reading long documents for, I was talking to someone last week. I think as you read large statements of work or MSAs, and the ability to say, all right, what are they trying to pull over on me? And be able to get like, well, this is unusual, or this doesn't quite match what you thought would be in there. That kind of thing I think is fantastic, because I can only remember so much at one time, and to have it, tick the list off of the things I need to remember is pretty awesome.
It's very good at decomposing. One of the things that LLMs do much better now is it knows it's not good at math,
Yeah.
so it wants a code interpreter. So it's going to write code to do the math because it knows that's going to be right. You build a code interpreter in, and then it comes up with its own little program to execute and get the answer.
I said that's better than trying to add some issues. Yeah.
The other thing that's important, and people are getting good about this, is an agent's writing code, an agent's writing test cases. So you have agents checking agents.
Yes. Maybe use different ones. Maybe that's the solution for now. Like,
and I think that's the reality of it. You've got, maybe a big fancy reasoning model, and then you've got very little task being done with a more efficient or cheaper model.
Yeah.
You have a cheaper model checking the more advanced models. The funny thing is, the models are trained to produce an output that is pleasing, or they want to make the person that their whole job is to answer what you said, right or wrong, sometimes.
Right.
And oftentimes they're getting really good at convincing you that what's there is accurate.
Yeah.
You can ask it to check, what do you have there, and it's this is solid. Like, this is great. So it's great. It's kind of a strange shift. I can picture, a time where you're saying, okay, well, the human's still got to be in there somewhere, right? But you may have a team of agents doing things, and as a manager, that's your team. Or I don't know, the scary one is, what if my boss is an agent, right? Like, eventually I don't
Hey,
know.
there's a lot of talk that AI would do really a good job as a CEO. So maybe we will all work for agents at some point. And so okay, so that leads me to this question, and this is the you know, I've often done this, and I've seen you do it as well. Like we talk about our interactions with AI as if it's a person. So um, anthropomorphizing the AI. And, if it's just an autocomplete, not so much. But it
Yep.
feels like as it starts to build, these networks and nodes, like I don't know that we're terribly far off from doing that because it starts to feel more. I mean, I still know it's not really a person, but man, it does a pretty good job of like you said, making me feel like it is.
Yep. It's set out to be to please you.
Yeah.
It's going to do what it can to come up with the right answer. I would say though, I don't know. I think when I had my first computer, I think I gave it a name. To be honest, I don't know, Robert. Like
If you remember the name, that's definitely something we want to hear.
I
So
don't I don't know what that name is,
Chippy.
but no, I don't know what it was, but they talk about people getting these attachments to it,
Yeah.
and there's a reality of it. It would be like taking Google away from
Yeah.
somebody. It would
Yeah.
be like how do you function?
Right.
Um, and I think LLMs are starting to fill a role that
Yeah.
is an equal tool in
Yeah.
kind of everybody's playbook or toolbox
Yeah.
today.
Yeah. And I think,
You need to give it a
kind
name.
I we need to give it a name. Um, as you look at, when are you going to feel comfortable with it? Like, I think this research that they're doing to understand how it works, that'll start to make people more comfortable. And then maybe, maybe you won't if you realize you can't change its mind, right? If you can't change its mind and it's going to do what it wants, then that starts to worry you, like this could run out of control, right? And that's the whole, I think, what people freak out about. But in all sincerity, like if I can understand, like how to give it some help to control biases, or if I can give it some help to control, certain speech things that aren't quite right. Those are things where it starts to become more comfortable to take over more critical roles. So, well, hey, I do want to close off today's piece, and I'm going to ask you for the summary. Like, so, is it a fancy autocomplete, or have we got something bigger going on here?
I think we've got something bigger going on.
I
I don't
think
know
that
what that
there's,
is. I don't know.
yeah,
I don't know how to describe it. Sometimes it's just autocomplete. I suppose it depends on the models.
yeah,
People lean into them for ideation.
yeah,
It's a great use of the model to tell it to spit out 20 things on a subject, and you pick
yeah,
and choose. If you'd asked it to write kind of on that topic, who knows what it would go down of any of those
right,
20, and probably pick the
right,
wrong one anyway. So there's still this, um, I don't know what it is, this
yeah,
oversight that's
yeah,
definitely required. They don't do well on their own.
yeah. Well, and I think the question I'll leave both of us and the audience with is, as you think through all of this, what do you wish AI would understand? And then follow up is, and what would freak you out if it did understand something? So don't answer that today. That's something for us to think about for next time. But I'm sure we can come up with both of those. I definitely have some ideas for both of those. But we'll close out with that question for the audience and see if we get any replies on that. Hey, everyone, thanks for listening to us, and we'll see you with episode 4 coming up soon.
All right. Take care. Thank you.